All right, good afternoon. This is the Math 150 College Algebra Review for Ms. Meador's Unit 1 test. So we're starting with question 1. Oh, by the way, if you do your practice test, you need to keep doing it over and over until you make 100%. That's an easy grade. And basically the test will be just like this with different numbers and such. So in question 1, it says find f to the negative 1, f to the negative 1 of negative 6, and f to the negative 1 of f of 1. So f to the negative 1 means inverse. So inverse means opposite. So to find the inverse, the first thing we're going to do is just switch the x's and the y's. So we got the inverse. Oh, we got to have set notation. Let me back that up. So we got set notation, and you're just going to switch your x's and y's. And we got negative 6 and 1. And negative 3, negative 5. When you're typing this on the computer, make sure you got your set notation, which they already do for you, but make sure you open and close your parentheses and separate with commas. All right? So that's the inverse. So then if it's asking you for the inverse of negative 6, so we're going to use the inverse function, which is up here, which we just did. Which one has x of negative 6? It's this one. So when x is negative 6 on the inverse, the y would be 1. So that's a 1 right there. And then function notation, if f to the negative 1 and f, they're inverses, they undo each other. So basically they just cancel each other out, and you're just left with 1. And that's question number 1. Okay, on question number 2, it says, shown on the grid is a graph of y equals the absolute value of x minus 2 and then minus 1. Use the graph to solve the inequality x minus 2 minus 1. The absolute value of x minus 2 minus 1 is greater than 0. Greater than 0 means we want to know where y is positive. What x values is y positive? Now, notice there's no equal to on it either. So these points that they show you on the graph is important. So that's where the y is 0. And from the graph, and I apologize, I'm not sure why this is, I copied and pasted this, so I guess that's why it's blurry. I apologize, I'll do better next time. It looks like it is 0 at 1, 2, and 3. Let me double check that real quick. That would be true. Okay, so at x equals 1 and at x equals 3, the graph equals 0. Well, we want to know where the graph is greater than 0. So that's everywhere up here like this, okay? So, but we want x values, so we want to read left to right. So on the far left, you're going from negative infinity all the way up to 1. So from negative infinity to 1, we have a positive y value. Since there's no equal to on the 0, we're going to put parentheses around the 1. Or, union notation, we get from 3 to infinity, we have y is greater than 0 as well. So 3 comma infinity, parentheses on 3, parentheses on that. And that's how you do it with the graph. Teachable moment here. What if they had asked where it is less than 0? That would have been in between 1 and 3. And if they had equal signs, you would put brackets instead of parentheses. Number 3 wants you to determine if y is a function of x. Now, to be a function, this is a linear function because it's to the degree of 1. So any line, any linear function is going to be, yes, a function. But there's also the vertical line test. So if you graph that on your calculator, go to your y equals screen and do y equals negative 11x plus 12, you're going to have a line, and it passes the vertical line test. But let me give you some examples where it doesn't. Sorry. So if I had a sideways parabola, that fails the vertical line test. That's not a function. If I have a regular parabola, that's a quadratic family. It's a family of functions. That's a yes. If I had a circle, that fails the vertical line test, so that's not a function. So you can graph it. If you have a graph, it has to pass the vertical line test. If it's from one of your families of functions, which if you took Algebra 2 or Pre-Cal, that's constant, linear, quadratic, cubic, square root, rational. All those functions are parent functions. They're families of functions. Number 4 says, Charles buys factory reconditioned hedge trimmers for $30 each and sells them online for $55 each. He has fixed costs of $700 per month. If X is the number of hedge trimmers he sells per month, then his revenue and costs in dollars are given by R of X equals 55X, C of X equals 30X plus 700. Find a formula for the function P of X equals R of X minus C of X for what values of X is his profit positive. Okay, so they give you the formula, P of X. Man, I hate it when I do that. P of X is equal to R of X minus C of X. So what you're going to want to do is substitute in R of X and C of X. So where the R of X is, we're going to put the 55X minus C of X. C of X is two things. It's a binomial, so you have to put it in parentheses. We got 30X plus 700. Now they're going to want you to simplify that. So you're minusing both, so don't make a silly mistake here. So it's 55X minus 30X, which is 25X, and then minus 700, which makes sense if you think about it, because your profit is your revenue minus your costs, and you knew it was going to cost $700 a month as a fixed cost. So you take that off the top, and then it's $25 is really what you're making on every hedge trimmer. Now, it wants to know when the profits are positive, so we're just going to set this thing greater than or equal to 0 and solve for X. So I'm going to add 700 on both sides, and then I'm going to divide both sides by 25. When I do 700 divided by 25, you get 28. And so 28 is the second part of the answer. Okay, number 5 one's even, odd, or neither. If you have a polynomial, when I mean a polynomial, when I say that, I mean like y equals something, x to a power like 4 plus bx to the third, blah, blah, blah. If you have a polynomial, it's really easy to determine even, odd, or neither. If all the degrees are even, it's even. If all the degrees are odd, it's odd. If you have a mixture, it's neither. So in this example, we have a polynomial, and the degree, it only has one degree, it's 6, one term, so that's obviously an even function, okay? Even functions are symmetrical across the y-axis. So if you wanted to graph it on the calculator, you would go to your y equals screen and graph x to the 6. It's going to look like a parabola except stretched vertically. Remember, you go zoom standard. And hopefully you can see the symmetry across the y-axis, therefore it's an even function. Now while I'm here, I feel like I should teach some other examples because you may not get one this easy on the test. So if I had given you the function y equals x squared plus 3x minus 1. Well, x squared is even, x to the first is odd. When you have a mixture, that's going to be a neither. All right? Oh, by the way, on the 1, that's x to the 0, so that is even. So if I were to graph that, I got x squared plus 3x minus 1, zoom standard. It's definitely not symmetrical across the y-axis. Now, an odd function is going to be symmetrical across the origin, or about the origin, I should say. And we'll look at one like that here in a minute. All right? So if I got y equals x to the third, that's obviously odd, and it would be symmetric about the origin. So if you graph y equals x to the third, if you rotate it 180 degrees about the origin, you get the same picture. Therefore, it's odd, and it's symmetric about the origin is odd. Now, The other thing I want to tell you, what if you don't have a polynomial? What if you have something that's like the square root of x? You can't use just the degrees. You have to graph it. So if you graph the square root of x, if you learned families of functions, you should know it starts at the origin and goes to the right. That is not symmetrical across the y-axis, and if you rotate it 180 degrees, you do not have the same picture, so that is a neither. Whoops. I think some of you may have one like this on a quiz. Also, if it has absolute value, you cannot use degrees. So you would need to graph it and look at it. So if you graph the absolute value of x, on your calculator, to do that, you go alpha, window, number 1. And if you learned your families of function, you know that's a V shape that sets at the origin, and the -3 is going to shift it down 3, but let's just do this for fun. That is obviously symmetrical across the y-axis, so this would be an even function. So number 6 says, write the equation of the graph after the indicated transformation. The graph of y equals the absolute value of x. All right, so we have a reflection on the x, in the x-axis. Some people say on. We have a stretch by a factor of 3, okay? And then we have translated 3 units to the left and up 6. We are doing the most. Okay, so first thing, if you have me in class, you know that there's 3 types of transformations. If you see add or subtract, that's a translation. If you see a negative, that is a reflection. And if you see multiply, that is a dilation. Well, we got all of this. And I'm going to start with the negative, the reflection. So a reflection, you don't want to be a reflection of somebody who's negative, so you want to be a reflection of somebody who's positive. So since you're reflecting on the x, x is going to stay positive. You're going to put a negative with y. So that means you're not going to put a negative inside with x. You're going to put a negative outside with y. And actually on C and D, there is no negative inside with x either, but they don't have a negative outside with y. So right there, you got a 50-50 shot. Okay, let's talk about the stretch. I'll tell you what I don't like about this question. They didn't say a vertical stretch, because it could have been horizontal, but it must be a vertical stretch because both of these have 3's on the outside. All right. Translated 3 units left. Now, x goes left and right. So with x, you're either going to add 3 or subtract 3. And one would think that 3 units left would be subtract 3, but if it's inside with x, it's actually plus 3. So both of those are correct. And then the up 6, up is a translation, so you're going to add or subtract. Up and down is y. So with y, you're going to do up 6 is going to be plus 6, which is going to give you choice A. Now, honestly, you could graph these on the calculator, okay? So if you go back over here and we graph the parent function, which is just the absolute value of x, and then if I put in my choice A, -3, absolute value, alpha window 1, x plus 3, and then outside I got plus 6. So here's the original. And so we reflected across the x, which means it would open down. It would open down, all right? Stretching means it's going to stretch it vertically, so it's not going to be as wide. It's going to be more narrow. And then it has moved left 3. Oh, wow. Left 1, 2, 3, and it's up 6. So you could keep doing that until you found the right answer. Okay, question 7, it says graph the equation, determine the domain and range, and whether y is a function of x. Now, if you know families of functions, you should know what cube root looks like. It actually looks like choice A there, and I might need to zoom. Yeah, there's 4 choices there. Here we go. It looks like either A or D. That's what cube root looks like, but then -4 is going to shift it down 4. So I'm looking, I think the choice is going to be A because I believe choice D is shifted right 4. But you got a graph and calculator. So go to your y equals screen, and to do cube root, you're going to go math 4. cube root of x, and then you're arrowing out and doing minus 4. And if you've already zoomed standard, that's all you got to do is hit graph. And you'll notice it's been shifted down 4, which is choice A. All right, choice A. And then it wants domain and range. All right, so domain and range, D comes before R, X comes before Y. Your domain are all your X values, your range is all your Y values. So when you're doing domain, you want to look left to right. Man, I thought my handwriting was bad on the regular board. Okay, so left to right. This graph goes left forever, it goes right forever. So the domain is negative infinity to infinity and beyond. Okay. The range are the Y values. Y goes up and down, so you want to look from bottom to top. So if you're looking, it's going down forever, it's going up forever, very slowly, but it is. So that's also negative infinity to infinity. And it wants to know, is it a function? Is Y a function? Well, yeah, I know it is because it's in the families of functions, but it passes the vertical line test. So it is a yes. Question 8 says, let g of x equal 3x squared plus 5x plus 3. Find g of p plus 3. Now, this is going to take a little bit of algebra work right here. All right? So everywhere that there's an x, we're going to put parentheses, and instead of x, we're going to put p plus 3. So to find the g of p plus 3, so the g of p plus 3, so everywhere there's an x, I'm going to put parentheses. So I have 3 parentheses squared plus 5 parentheses plus 3. And instead of x, I'm putting in p plus 3. Now, to square a binomial, you don't just square each term. You have to multiply it times itself. So you're going to need to write it out. So this is 3 times p plus 3 times another p plus 3. All right. If you want to go ahead and distribute the 5 over here, you can. That gives me 5p plus 15 plus 3. But to multiply this, some teachers teach full. I just teach distribute twice. So my 3 is going to be chilling out front. And I'm going to do p times p and p times 3. So p times p is p squared. P times 3 is 3p. And then I got to take the 3 times both of those. 3 times p is 3p. 3 times 3 is 9. Okay? Some people teach FOIL. First times first, outer times outer, inner times inner, last times last. You do it however you want to do it. Before I combine like terms over here, or in the parentheses, I'm going to go over here where I have plus 5p. I'm going to go ahead and combine the 15 and the 3 to get 18. And then before I distribute the 3 to the parentheses, I'm going to combine the like terms. So I got 3 parentheses p squared, 3p and 3p is 6p plus 9, plus 5p, plus 18. Now you distribute the 3 to everything in the parentheses. And distribute means multiply, so we got 3p squared plus 18p plus 27 plus 5p plus 18. This is an algebra workout, okay? And then you still got like terms. So nobody is like 3p squared, so you're just going to rewrite it. 18p is like 5p. That's going to be 23p. So plus 23p. And then 27 plus 18. What's that, 45? I think. Yep. So there's my answer. That is a longer problem. So everywhere there's an x, you put parentheses, you plug it in, and then you really got to watch your algebra steps in the middle. Okay. All right, number 9, we got let f of x equal stuff, g of x equal some more stuff, h of x, more stuff. Now, this is called composition of functions. It wants you to find, that's not multiply, that's of, g of h of f of 5. So you're going to start with the innermost thing. So the first thing you're going to do is find the f of 5. So that means you're going to use the f equation. So instead of f of x, though, everywhere there's an x in that equation, we're going to put parentheses. And instead of x, we're going to put 5. Oops. Do it every time. So I got 5 right there, 5 right there. And so the f of 5 is going to be 8 times 5, which is 40, minus 2. I'm going to get 38. So the f of 5 is 38. So that means over here I'm left with g of h of 38. So now I'm finding the h of 38. So I'm going to go to the h equation, and everywhere there's an x, I'm going to plug 38 in. So h of x, h of stuff, equals stuff plus 2 over 8. And instead of x, I'm plugging in 38. 38 plus 2 is 40. 40 divided by 8 is 5. So where the h of 38 is, that's really just finding the g of 5. Okay? So you're going to use the g equation. I'm going to do this down here. The g equation says g of x. Everywhere there's an x, we put parentheses. And instead of x, we're going to put a 5. 5 squared is 25. 25 plus 3 is 28, which is the final answer. Question 10 is another composition of function. It wants you to find the f of g of x. Open circle means of. So I'm finding the f of g of x. That's how I like to write it. You're still going to start on the inside. So where g of x is, we're going to plug in what g of x equals. It equals square root of x. And then you're finding the f of stuff, so you're going to use the f equation, and everywhere there's an x, you're going to put parentheses. So the f of stuff is 9 times stuff plus 5, and instead of x, we're going to put in square root of x. And the nice thing on this one is you can't really do anything. So 9 times the square root of x is just 9 square roots of x plus 5, and that is the f of g of x. Okay, number 11 says sketch the graph and state the domain and range. Identify any intervals on which f of x is increasing, decreasing, or constant. And your function is the square root of 25 minus x squared, which should be a semicircle. It's a part of a conic section. So we're going to use our handy-dandy calculator over here. And so I'm going to type in the square root of 25 minus x squared. And I've already zoomed standard, so I'm going to hit graph. So you only get the positive value. Now, should anybody miss that? No, because you got a graph and calculator. Now, they're trying to trick you with this because if you did plus or minus, it'd be that. But it's only wanting you to graph the positive, the principal value. Now, domain, remember domain is x. X goes left to right. So you're looking left to right. Anybody want to guess what numbers those are? That's going to be 5 and negative 5 because it's the square root of that. So our x values go from, and you can also zoom in on the graphs when you have the Math Excel open. So our domain is going to go from negative 5 to 5, and it touches there because you can see the closed dots. That's your domain. The range are the y values, which go up and down. So how far down does the graph go? Well, it goes down to 0, so it starts at 0 and it touches at 0, and it goes up to 5. So 0 to 5 with brackets because it's touching at that point. By the way, that's the top half of a circle whose center is at 0, 0 and has a radius of 5. All right, now next it wants to know where the function's increasing. So it wants to know where y is increasing, but in terms of x. So if I look at this graph and I read left to right, the graph is increasing from negative 5 to 0. Now I might have a question here because I feel like on Math Excel, they use parentheses. All right, it also wants to know where it's decreasing. Well, it's decreasing from 0 to 5 because it's going downhill right here. So that's, you're looking at your x values. You're reading left to right. Your answers in terms of x. So 0 to 5. Okay, it wants you to determine whether, on number 12, whether the given function is invertible. If it's invertible, find the inverse. Well, inverse means you switch x's and y's. So I'm just looking. Yeah, it's definitely invertible. So all you got to do is switch all your x's and y's. So the inverse is going to be set notation, which they already have for you there. It's going to be negative 2, 6, negative 5, 2, negative 6, 1, and 4, 5. All right, 13 wants you to use transformations to graph the function and state the domain and range. Well, we can use transformations. Minus 6 with x. X goes left to right. You think minus 6 would be left 6, but it's right 6. Plus 4 is a translation. It's not with x. It's outside with y. So y goes up and down. It's going to be up 4. Remember, you only do the opposite with x. But you have a graphing calculator. So don't take any chances on the real test. So you're going to go y equals, you're going to go alpha window number 1, x minus 6, go outside, you got plus 4. You graph it, and you can see on the graph it's going right 6, up 4. Now, when you use the tool on Math Excel, you're going to click the V, I believe it's a V, and then it's going to want you to click more than one point. So the vertex is 6, 4, right? That's easy. But if you need another point, remember you have a graphing calculator that makes a table. You can always go to the table and pick another point. So 6, 4 right there, there's your vertex. And then you could just go right 1 and then down to 5 to get, or up to 5, excuse me, to get the second point. Okay, it wants to know domain and range. Domain is x. X goes left to right. Okay? So the graph goes left forever, it goes right forever, so that's negative infinity to infinity. The range are the y values. Y goes up and down. So how low does the graph go? Where the graph, it only goes this low, which is 4. So it starts at 4. Actually, it touches at 4. So let me change that. Starts at 4 and goes up forever to infinity. Okay, number 14 wants to know if the relation is a function. Now, you could do the vertical line test if you want to plot all these. But remember, the definition of a function is each x, each girl, can have only one y, one guy. If the y has more than one x, that's okay. But each x can have only one y. Well, I'm seeing, look at your girl 1. Your girl 1 is seeing 2 different dudes. So x's are girls, y's are guys. For something to be a function, a girl can have only one guy. So your x is messing that up. She's seeing 2 dudes. That is not functional. Let me give you a quick example. Whoopsie. If it had been this, 1, 2, 2, 3, 4, 2, and they ask you, is this a function? Some people will say no because the y's have different x's. But that's guys. Y's, in our society, they say that's okay. So that is a function. So it's only if you're girls, the x's have more than one guy, then that's not a function. All right, number 15 says let g of x equals 6x plus 7. Find x if g of x is negative 23. So make sure you RTFQ, read the freaking question. All right? It wants you to find x. It's giving you the y value. So in the equation, you're going to put negative 23 in for g, and you're going to solve for x. This is an easy Algebra 1 2-step equation. You're going to minus 7. Well, no, I'm going to move the board first. You're going to minus 7 minus 7. We got negative 30 equals 6x. You're going to divide by 6, divide by 6. We got negative 5 equals x. Yes, that's a negative 5. Thank you. All right. It says consider the graph of y equals the cube root of x plus 1. That plus 1 is not with x. It's outside with y. So it shifts it up 1, but look, they give you the graph. Is it a one-to-one function? Now, we got to be careful right here. You do a vertical line test to determine if that graph is a function. There's the horizontal line test to determine if it's a one-to-one function. Well, this passes the horizontal line test, so yes, it is one-to-one. Let me give you an example of one that's not. So if I gave you a parabola, the parabola passes the vertical line test. That is a function. But it fails the horizontal line test, so it's not one-to-one. So horizontal line test tells one-to-one. Vertical line test is just a function. Number 17. Construct a function that... Oh, wow, that was an inadvertent boo.
That sounds like a cow.
I am recording. Construct a function that expresses the relationship in the following statement. Use K as the constant of variation. Your score in a band competition, W, varies directly as the number of hours that you practice. Now, varies directly means it's going direct across. So the key phrase is W varies directly with number of hours. So that's W equals K times R. If it had said varied inversely, it would have been W equals K over R. That's inversely. So direct, you just go straight across. Suppose Q, all right, so we got another direct variation problem, or maybe not direct. Q is directly proportional to what? The square root of H, and inversely proportional to the cube of J. Let's just write that down. Q is directly proportional, so that's going to be K times the square root of H, but inversely, so over the cube of J. That's the formula you have to work with. Now, there are other ways that teachers explain this. I'm just going to go with one way and stick with it. So I'm going to plug in my Q, my H, and my J, and I'm going to solve for the constant of variation, because sometimes they ask you to solve for the constant of variation. So Q's 24. K I want to solve for. H is 4. J is 2, so we're going to cube that. All right, the square root of 4 is 2. So we have K times 2, or 2K. 2 to the third is 8. 2 times 2 times 2. I'm going to solve for K. I'm going to multiply by 8. And I get 8 times 24. I think that's 192. Probably should use the calculator to double check it since I am recording. All right, 192, and then I'm going to divide that by 2. Now, if they had asked you to find the constant of variation, you just did it. But they did not. They ask you to find Q when H is blank and J is blank. So you're going to go back and use this equation. Now we got Q equals, we know K is 96. And where the H and the J are, you're going to plug in H, you're going to plug in J. So Q is going to equal 96 times the square root of H, H is 16, over J cubed, so that's 1/3 cubed. You actually could type all that in the calculator at one time. Hey, Nike, just do it. Here we go. Make a fraction. We got 96, square root, 16. That's going to be 4 times 96. And we're dividing by the fraction 1/3 that's being cubed. So that's 1 over 27. And the calculator does it all for you. Dang, that's big. Okay. It's right, though, because you're going to have a big number on top, 96 times that, and then you're dividing by 127. So 10,368. I bet that's what y'all are going to guess anyway. Okay, number 19 is a piecewise function. I want you to graph the function, state the domain and range. The first line is y equals x plus 3. So that is the parent function, y equals x, that's been shifted up 3. The second one is y equals x shifted down 3, but you're only going to graph the first one when x is greater than 1 and the second one x is less than 1. You can do this on the calculator. So if you go to your y equals screen, if you put the function in parentheses, x plus 3, and then out beside it, you do the parentheses in the domain, x is greater than, you're like, where do you get greater than? Second math, number 3. X is greater than 1. All right, then go down to the next line, and I'm going to do the function in parentheses, x minus 3. The domain is x less than or equal to, where do I get that? Second math, the test menu, number 6, 1. And you hit graph, and you hit graph. Okay, so we know it's not B, and we know it's not C. All right, it possibly could be A or D. It depends on the closed circle, open circle. So notice, this is the closed one. It's going with the line y equals x minus 3. Y equals x minus 3 is the lower one because it's been shifted down 3. So the closed circle should be here. So the answer is D. Now the domain, it goes left forever. It's going down, but it's going left forever. It goes right forever, and it has a value for x equals 1. So the domain is negative infinity to infinity. It goes left and right forever. Because it does allow it to, see, this is your domain. Less than 1, greater than 1, and including 1. That's all real numbers. The range are the y values. So over here, it goes down forever, it goes up forever, but we got a gap. So we're going to have to use an OR thing. So we go from negative infinity. Now these are y's, so it goes down forever. And then it goes up to this point on the graph. I wonder what y value that is. Well, that's when x is 1 in the second equation. 1 minus 3 is negative 2. So the y values go down forever and up to negative 2, and it touches at negative 2 because we have a closed dot. Okay? So that's a bracket. I don't know if y'all can tell that. Probably can't. That's a bracket. Or union symbol. Now we jump up here. That's called jump discontinuity to this y value. So plug 1 into the top equation. 1 plus 3 is 4. So it jumps up to 4. Goes up forever to infinity, but it doesn't touch 4. So parentheses and parentheses on infinity. Find a formula for the inverse of f. Okay, inverse means opposite. So what we're going to do is we're going to switch our x and our y. So here's x, this is your y. So where y used to be, we're going to put x. Where x used to be, we're going to put a y. So once you switch them, then you just solve for y. So how do I get y by myself? Well, the opposite of the cube root is going to be raised to the third power. Just a second. So I'm going to raise the right to the third, raise the left to the third. So on the left, I got x cubed. On the right, the cube and the cube root cancel. We have y minus 9, and then you're just going to add 9, add 9. And so we have x cubed plus 9. That's not just equal to any y. That is the inverse, which is f to the negative 1. All right, number 1 says determine whether the given pair of functions graphed at the right are inverses. So what you should, air quote, should have learned in class is that inverse functions are symmetrical across the y equals x line. They have that line graphed in here for you. So are the red and the blue lines, sorry if you're colorblind, are they mirror images of each other? No, they're not mirror images of each other, so they're not inverses. Let me see if I can give you an example of some that might be. So on the graphing calculator here to the left, there's two functions, and I can't put them in color because I don't have the color edition of the graphing calculator. I'm not bougie like that, but you got your y equals x line down the middle, and then they're mirror images of one another, so those would be inverses. And by the way, that's x to the third and the cube root of x, like you cared. Okay. Number 22, the pressure exerted by a certain liquid at a given point varies directly as the depth of the point beneath the surface of the liquid. The pressure at 80 feet is 400 pounds per square inch. What is the pressure at 20 feet? Okay, we got to come up with a formula. And I know you don't have to solve for K on this one. There's other ways to do this one. I'm going to stick with it because sometimes I might ask you to solve for K. So it says pressure exerted varies directly as the depth. So pressure varies directly as depth. And it tells you the pressure at 80 feet. It's not saying the pressure is 80 feet. The pressure at 80 feet, that's depth. So the depth is 80. The pressure is, pressure is 400 pounds per square inch. So we can solve for the constant of variation. You're going to divide by 800. I'm pretty sure that's going to be 5. All right. So now you can rewrite your equation as P equals 5 times D. And then it says, what is pressure? Find P at a depth of 20 feet. So you put in 20, 5 times 20 is 100, which is what I hope you make on this test. I got it. Okay. Determine whether the first variable varies directly or inversely with the other. Write a formula that describes the variation. What? Hold on. Okay, number 23, sort of a weird question. It says, determine whether the first variable varies directly or inversely with the other variable. Write a formula that describes the variation. Well, it says the length of a 40 square foot door. The key right here is square feet. That is an area. Area is 40 square feet or feet squared. And it's talking about length and width. So the first variable is length, the second variable is width. And area is a constant right now because it's telling you the area is 40. So how do you find the area of a door? It's length times width. Well, they're telling you the area is 40 square feet. And so if you were to solve for length, the first variable, because it says, look, length equals, wow, can't talk. You would solve for L by dividing by W. All right, so 40 over W is equal to the length. All right, so that's your equation, and that's inversely. Length varies inversely as width, and the K here, the constant, would be 40, the constant of proportionality. 24, let f of x be the square root of x and h of x be 1 over x minus 4. Find f minus h in its domain. So that just wants you to take f of x minus h of x. Well, f of x is this minus h of x. That's that. And notice they're not even going to make you get a common denominator. Okay, that's the easy part. Now, domain is important. Domain means what are the restrictions on x? In my class, I preach that there's 3 things you can't do in math. You can't do that. 3 things you can't do in math. First thing, you can't divide by 0. Second thing, you can't take the square root of a negative number. And the third thing is you can't take the log of 0 or the log of a negative number. Okay, I'm going super fast, but you can pause it and rewind it. So now, in this problem, we have 2 of these things. We have divide and we have a square root. So first thing is, I can't divide by 0. So that means that x minus 4 cannot equal 0. So if you solve that and add 4 to both sides, that tells you x cannot be 4, period. All right, the other thing I have in here is a square root. So I can't take the square root of a negative, so what's inside of there has to be greater than or equal to 0. So It wants interval notation. You can see we got to be greater than or equal to 0, but it can't equal 4. So we're going to start at 0, equal to 0. We're going to get close to 4. Not sure why that won't write all of a sudden. All right. But we're not going to touch 4. We can't equal 4 because if we have 4, 4 minus 4 is 0. You can't divide by 0. Union symbol, then we're going to jump on the other side of 4 and start all over and go to infinity. Now, I think I can graph this. Let me do it real quick. So I graphed that. I typed it in just like I saw it. Square root of x minus the fraction 1 over x minus 4. There's a vertical asymptote at 4. That's when you had to divide by 0. And the graph starts at 0. If you needed to look at the x values, you could always go to the table set, start at 0. And if you go to negative numbers, you have an error because you can't have a negative x because then you have square root of a negative. And if you get it 4, there's an error. Whoa, not sure what happened there. Okay. Okay, question 25. It says let f of x equal x minus 1, g of x equal x squared minus 1. Find and simplify the expression f plus g of 3. I like to do it like this. Find the f of 3, find the g of 3, and then just add them together. All right? So I'm going to use the f equation and plug a 3 in. Everywhere there's an x, I'm going to put parentheses and plug in 3. So that's 3 minus 1. That's going to be a 2. In the g equation, everywhere there's an x, I'm going to put parentheses. So x squared minus x. And I'm going to plug a 3 in. You could type all this in the calculator. We got 9 minus 3, which is going to be 6. And we got 2 plus 6, which is 8. So just put the 3 in the f, put the 3 in the g. Parentheses are important, though. I do have a little disclaimer on 2 problems, numbers 4 and 11. On number 4, we had set it greater than or equal to 0. So I'm going to go back and do that problem. It just has to be greater than 0, and this is a little tricky. So we did revenue minus costs, which we've already done that. So it was 55x minus the cost. So you got to minus both of those. So that is 25x minus 700. But we got to make it greater than 0 because it wants a positive profit. 0 is not positive. So when I add 700 to both sides and I divide by 25, okay, if you recall, 700 divided by 25 is 28. We have to have a number greater than 28, so it's got to be 29. To me, that's a trick question. Okay, second disclaimer, number 11, it wants to know where the function's increasing and where it's decreasing. So our answer was B, all right? The function's increasing here, so those x values are from -5 to 0. They want you to use brackets, okay? Calculus people disagree with that, but it is what it is. The function is decreasing there, which would be from 0 to 5. So make sure you use brackets on those. Whoops, brackets, hello. And that's all. Hope this video helps you. Stop it, rewind it, pause it. If you got questions, you can feel free to send me a message on Facebook. My name's April M. Harris. And good luck.